Today we are going to be identifying elements in stars based on their absorption spectra. An absorption spectrum, or spectral lines, is a distinct pattern of the electromagnetic spectrum caused by an element absorbing specific wavelengths of light. The dark bands represent wavelengths of light absorbed by the atmosphere surrounding a star or planet. On the following slides, the absorption spectrum of the atmosphere around a mystery sun is shown on the far right. Use the spectra of the elements shown to determine what elements are in the atmosphere of each mystery sun. Let's do number 1 together for practice. On the right side of the screen is our absorption spectrum for our mystery sun. The remaining spectra to the left each represent the absorption spectra for specific elements. The black bands are the wavelengths of light that those elements absorb. What we want to do is find unique banding patterns in our mystery sun that match with unique banding patterns in elements. For this sun, there are 2 elements in its atmosphere. So we are looking for 2 elements that have banding patterns matching our mystery sun. The first pattern I notice right away is near the 400 nanometer mark. I have a fairly dark line in our mystery sun, and then there's no line until after 450 nanometers. So if I compare this to sodium, I know sodium is not in my mystery sun because there's some distinct banding here in sodium that's missing in our mystery sun. The same thing goes for sulfur. I have bands above the 400 mark that are not found in my mystery sun. Nitrogen is the only element that has that distinct band there without additional banding around it. I also notice near the bottom of the spectrum for nitrogen, there's a unique set of bands near the 650 nanometer mark in nitrogen that's also present in my mystery sun. My mystery sun has additional bands though, like this one here, and the band below that 700 nanometer mark. The only element that has that band near the 700 nanometer mark is carbon. And again, if I were to look at each band on carbon, those would be represented in my mystery sun. So based on what I'm seeing, carbon and nitrogen are the 2 elements in this mystery sun's atmosphere. All right. On this slide, it shows that indeed carbon and nitrogen are my 2 elements. It also lines up some unique bands from each element to those same banding patterns on my mystery sun. What I would like you to do on question 2 is look at the mystery sun and compare it to the spectra for the elements on the left. Pause your video and figure out which 2 elements are in this mystery sun. When you continue to play the video, a question is going to pop up asking you to put in what you think is in the mystery sun. Enter your answers, and then it will show you if you are correct or if you need to rethink the question. Mystery sun number 2 is on the right, and your elements are on the left. What elements are in this mystery sun? If we look at the banding patterns in nitrogen and sulfur, we have some really distinct banding that lines up with our mystery sun. For sulfur, those distinct bands are around the 400 nanometer mark and the 550 nanometer mark. For nitrogen, we have the unique banding around the 650 nanometer mark that lines up really well with the bands on our mystery sun. For practice question 3, we're going to make things a little more challenging. This mystery sun will have 3 elements in its atmosphere. Just like before, pause your video find the 3 missing elements, and then enter your predictions in the pop-up question box. What we see in Mystery Sun number 3 are the elements hydrogen, carbon, and sulfur. Again, we're looking for distinct banding patterns. What's challenging about hydrogen is that its spectrum is not particularly interesting. The only band that it has that really makes it stand out from the rest of the elements is that band near the top between the 400 and 450 nanometer mark. It's very faint, so it's hard to see. On this Mystery Sun, we can also see hydrogen's band around the 650 nanometer mark, but we see that band is also present in carbon, so that can be hard to distinguish between carbon and hydrogen. Click Next to access question 4. Right. Question 4 is going to show you a mystery sun, and again, there are 3 elements in this sun's atmosphere. Can you find all 3? In this mystery sun's atmosphere, we have oxygen. The really distinct banding pattern on oxygen is right around the 700 nanometer mark, where we have 3 faint bands. We also have sulfur with that distinct double band around the 400 nanometer mark, and that series of bands around the 550 nanometer mark. And finally, we have sodium. Sodium is really noticeable because it has that thick set of banding right at the 450 nanometer mark. Question 5 has a mystery sun that, again, has 3 different elements in its atmosphere. See if you can find all 3. This mystery sun has hydrogen, oxygen, and nitrogen in its atmosphere. Again, we're looking for unique banding patterns for each element. Question 6 is the final question, but it's the most challenging. In this one, you are looking for 4 elements. See if you can find all 4. All right, this one was hard, but the 4 missing elements, or present elements, are carbon, oxygen, nitrogen, and sodium. So first, we are linking up those distinct bands with sodium. That band at 450 nanometers is what shows us that, for sure, sodium is in our mystery sun. For nitrogen, the distinct banding is really around the 650 nanometer mark. We do have a band at right around 400 nanometers that also sticks out, but the banding at 650 is the signature for nitrogen. For oxygen, we're seeing some of that banding right around the 550 nanometer mark, and then again, that triple banding down by the 700 nanometer mark. Now that banding looks a little bit different in our mystery sun because we're also getting that distinct band around 700 nanometers from carbon, and it's blending with the bands from oxygen to make it look like a new unique pattern that we haven't seen before. All right, what I would like you to do is go ahead and move on to the next step of this assignment. If you have questions, please email me and let me know. Thank you.